AI agents are the future of AI. A statement like this, or some variations of these statements, I'm pretty sure I've been hearing for the last 1.5 years. And it's indeed true. It has already taken the organizational productivity up by close to 50% if properly thought and if the use cases of agents are properly thought. So in this video, we are going to understand what are agents and what makes it different than an AI assistant or a RAG system, right? We're going to understand some behind the scenes of what is exactly happening when you put a question on ChatGPT and the first word that you see is thinking. Are they really thinking? We're going to understand when people say that agents can reason. What does this reasoning actually mean? Is it different from how we reason as a human, right? And we are also going to look at some of the use cases that I have personally seen work for AI agents and have actually benefited the organizations a lot. So with that, let's get started. Welcome to the era of AI agents. Let's try to understand how we should approach. But let's start from the beginning, just to set the context. Let's look at a timeline, and there are 3 shifts that I thought I'll just divide it into. The shift 1 was November 2022, and we all know what happened at that point of time, right? So we got access to ChatGPT. We came to know there is something called generative AI, which also exists in the world of AI, that common people can go ahead and add it, right? So this is what happened. So we started our shift towards reasoning model at scale, starting with LLMs, right? So we just got access to LLMs and people went crazy. They created poems, they created a lot of stories, creative stories. People understood that it can articulate on my behalf, right? People also realized that in their organizations that it can do a lot more than just writing poems for me, and they started using it for their own benefits. Shift 2, which is around 2023 and 2024, we got access to compound systems, and we started creating knowledge boundaries for LLMs, right? We knew that the hallucination is a part of LLMs. So if I have to use it in my organization, I have to make sure that I control that hallucination. And compound systems helped us to basically create knowledge boundaries. And we introduced something called retrieval augmented generation. There's a video on that, specific video on RAG. If you have not watched it, I'll strongly recommend that you go ahead and do that to understand the foundation of that. But in this case, these 2 years are the foundations of compound system. And then in 2025 and beyond that also, it will also happen in 2026. It's going to happen in 2027 as well, is the Agentic framework, basically making AI plan and act. So in this shift, from shift 2 to shift 3, AI said, in shift 2, AI said, this is what you can do. And in shift 3, agent said, let me do it for you, right? So that's the major shift. Now, there's a limitations in 2022 we had. Imagine that we had a chat bot in 2022, and we go ahead and ask it that, hey, can you plan an itinerary for me for Goa? And LLMs don't say no to you in very specific cases. It will say no, but mostly they will go ahead and give you an answer. And in this case also, it will probably come up with an answer like this, that hey, it's a beautiful destination known for its stunning beaches. Day 1 you can do this, day 2 you can go to North Goa, etc., etc. But one thing you are absolutely sure of, that this certainly doesn't work, right? Why? Because when it is planning my itinerary, it doesn't know me. It has not asked me what I like to do. Do I like to go to North Goa, or I like quieter places? Do I like to go to South Goa? It does not ask me what I'd like to do. Am I someone who is just sitting relaxing on the beach, or I want to go like some paragliding or something else, some power sports? It does not ask me anything. It does not ask me what type of food I would like to take, right? And this is where I think RAG started giving us more specific answers. So when this happened, we can program a Google search tool or make LLM ask a specific clarifying questions like, what is your budget? How do you want to go? Do you want to take a train or do you want to take a plane? And we can give it more access through APIs to basically book tickets in Indian websites like ClearTrip or Make My Trip or etc. Right? Or even from the websites of the like aeroplanes or airplane companies. But now what we see that when after knowing all these things, when it comes to a response, this is much better because it has spoken with me. There is a to and fro context switching and context gathering that we made it do with the users, which basically helped to get the answers. Now, when it comes to agentic AI, there's a confusion as of today. Like, which use case should be agentic and which use case should not be agentic? And there is a reason. You should not go ahead and make all use cases agentic just because you have access to the technology. And I'll tell you why. But in my opinion, if as a developer, I know the path to the solution, right? So I'm building a tech solution, and I know that what needs to be done. For example, in the case when we showed you this, that a new chat applications where we are making it ask. So I know that when user asks the question, I have to first make it ask clarifying question. If user says that, hey, we need to take a flight on this date, use Google search to basically try to find available flights, give options to the user. If user selects, then go ahead and book this flight, then you come back and do certain things. So all the steps are known to us, right? And in technological terms, we call it control logic of the program, right? So if the control logic of the program is known to the developer of the tech solutions, in my opinion, the use case should not be agentic. So in this case, I will not go and introduce a reasoning model probably in this chat application. The reason is agents are slow thinkers, and we'll go a little deeper into this pretty soon. But what type of use case, if I try to keep this example in mind, a chatbot, what type of questions when users ask should be agentic, right? So creative travel itinerary for me is not an agentic. Then what type of questions? Let's say I go ahead and ask a question that, hey, I'm going to Goa. Tell me how many sunscreen lotion I need to take with me. Now, as a developer, I don't know how to go ahead and find that out. And here I'll probably try to bring an agent who can reason it better, saying that, hey, first I'll go ahead and check how much sunscreen lotion is good for a human body. Then I'll probably use a weather tool to check when the person wants to go to Goa, if sun is at all there or not, right? And it will do certain steps to reason, plan its own task and go ahead and give me the answer, right? At the end. So that should be an agentic use case. So now, as we discuss, the control logic of the program can be defined programmatically, like the path is known to us, as I said, or it can be defined by LLMs, right? And when it defined by LLM or a large reasoning model, that time we say that it's an agentic use case, right? So if you look at the two sections out here, when it is defined programmatically, the query comes, there is a step 1, there is a step 2, there is a step 3 and step n, which is all programmed by the developer. And then the knowledge base or whatever is gathered is given to an LLM to craft a response, right? Which is whatever information is gathered from step 1 to step n, and the response is shown to the user. Whereas when it comes agentic implementation, if you notice, the LLM comes in the front, right? So you have query, then you have LLM who is reasoning, trying to understand what should be the steps, right? And then decide the steps and says that, hey, step 1, it can distribute the step 1 to another different agent, right? So agent 1, step 2 and step 3, which can go together to agent 2 and agent 3 after agent 1 completes its work. And then another feedback loop of analysis happens. So agent 1 and agent probably would report to the initial LLM which reasons and created the task, and the first LLM would probably take some decisions based on that, and then only it will give a response to the user. And this feedback loop that you get to see here is making the user a lot more the agents a lot slower to work, but they are and that is why they should be deployed in a highly complex task where the reasoning is a lot more, right? So with that, if you look at this mental model that I have prepared for you, your assistants control the logic, RAG solutions. And even though the shift 3 has happened, the RAGs are always there. So they are still there. More than 95% of the use cases that are done in organizations today are RAG use cases, right? And you have the assistant control the logic, right? So query comes, it tries to understand, runs some logic, which is basically your RAG workflow, and gives you the response, right? So use cases where we know the path. Whereas when it comes to agentic control logic, the query is asked, it's understand, then the reasoning model plans the task, it tries to understand what type of tools it has with it to basically act on it, then it observes, then if needed it iterates and goes on and on before it actually gives you the response. So workflows, so when do we use assistant? When use cases where we know the path. When do we use agentic? Workflows where we want LLMs to reason, right? So now I've been talking about reason a lot more, right? So let's go a little bit deeper into reasoning. What is this reasoning, and is it different from how human reason? Like, what is the distinction? How we think versus how they think, right? How do they think? Now, you can see that human reasoning is based on genuine understanding. There's something, the neural network, which is again an entity relationship that we have built over time since our childhood, right? It's a huge net, and we have a genuine understanding of that, right? And there's a term that I always use, which is called embodiment. So our brain is embodied into this universe, right? Whereas the LLM is probably inside a server room. Now, how does it differentiate? Now, if I touch a hot cup of coffee, I know that it is hot, right? You can give it to a kid, and that kid will probably take the hand away quickly. It doesn't have to reason whether it is hot and cold before it takes the hand away, right? That's how the brain is reasoning. Whereas LLM's reasoning, doesn't matter how big the LLMs are or how big the reasoning models are, they have to know it. It's a pattern recognition that they do, right? There's a true common sense that human has, right? Which means that if you give a pencil to a 5-year-old kid and ask that kid to drop the pencil, like if you drop the pencil, where the pencil will go, the kid will say it will go down. It has not read the gravitational Newton's gravity. It doesn't know what is gravity, right? It doesn't have to know that there is something called gravity and G equal to 9.8. It is like towards the center of the earth. It is pulled at this rate. But LLMs need to know that. You need to feed that information, right? You need to feed that information into LLM's brain when you create that artificial neural network. There are intent and belief that humans have, right? This is driven by goals, emotions, and subjective experiences. What I mean, if you enter a kitchen and suddenly you see that there is water below the sink, immediately you know that probably something wrong with the sink. Maybe there is no other water nearby, right? Your brain is processing that, but it is coming instantly. Like you have a gut feel. LLM's reasoning doesn't have that gut feel, right? It knows the pattern of the language, not the meaning behind that, right? And that is why, if you go back when I was saying that the first time when you say 1 plus 1 to ChatGPT and it says 2, it is not calculating 1 plus 1 equal to 2. It has understood the pattern so nicely that it gives you the right answer, because it has seen typically 1 plus 1 is equal to 2, right? So with that, I gave these two questions to two models. One is ChatGPT 4o Mini, which is a pretty good model, but reasoning capabilities are not that great. And then I gave the same question to ChatGPT's O3 Mini, which is a reasoning model. The question is, you bought 44 QEs on Friday, you bought 58 QEs on Saturday, and on Sunday you bought twice as many as you bought on Friday, but 5 of them were smaller. How many QEs you have? That's a simple question, right? Not a complex mathematical question. But 4o Mini, if you look at this calculation, it correctly calculated everything, but then there is a -5 bracket, it says smaller QEs, and the answer is 185, right? Now, every model reasons, and even GPT 4o Mini has also reasoned it. It probably reasoned that because they are smaller, the user just threw it, right? So let me take it away. Whereas when you look at how O3 Mini has responded to this, if you look at the point number 2 under point 3, it says that 5 of them are smaller, simply tells you that 5 of the 88 QEs are smaller in number, smaller in size. They still count as QEs, and it gives you the right answer, which is 190 QEs, right? Now, why does it happen? This happens because of something called probabilistic pattern matching. So in the instructions of these LLMs, it was told that try to understand the genre of the question that is asked. If it is mathematics, then every information that are there in that prompt has to do something with the answer, so carefully think about it. And that's how it is trying to understand that in the first case, the first LLM thought that, okay, let me throw it away. In the second case, when the reasoning is a little bit more, it says that, well, you asked me how many QEs? QEs are still 190, right? Here's an example. So, there is another concept that I would like to bring up, and the reason it's a concept of LLMs, but because when it comes to agents, the brain of agents is still a large language model and a large reasoning model probably, right? There's a concept called token bias, right? How, when you ask a question to something like a ChatGPT or Gemini, and you get a response, if you tweak the question, keeping the meaning alive, you will see that the response is also changing, right? And this phenomena is called the token bias of this application. And if you see in this example, the prompt A, Andrew is free from 11 a.m. to 3 p.m., Bob is free from 12 p.m. to 4 p.m., what time they both are free, gives you the correct answer, most likely. But the same thing, instead of free, when you ask that what time they are both available, sometimes it gives the wrong answer because of token bias. Now, token bias is not always a negative entity, but I'm just saying that when you change something in your question, your response from LLM also changes. But now let's try to combine token bias and the reasoning that we learned just now into a real examples. Let's look at Linda problem. It's a well-known conjunction fallacy. You can read about it, but I'll give you a quick understanding what this experiment was. So it's a classic psychology experiment that was done by Daniel. In this experiment, the question that was asked to participants that Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was very deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which is more probable? Linda is a bank teller, or Linda is a bank teller and is active in feminist movement? Now, the information that was given in the question confused the participants against the mathematical probability, right? So, in the second option, even though because of the information that was given into the question seems like the right answer because it says feminist movement, but mathematical probability wise, the first one doesn't have an end, right? So it is always a more probable, because there is only one probability that you are dealing with. In the second one, you are dealing with two probabilities, right? You can read a little bit more about it, but here I'll show how, when I gave it actually to some reasoning models, how did they act, right? So I gave this question to 5.1, ChatGPT 5.1 thinking, which is almost the latest one, latest reasoning model of ChatGPT. And it correctly said Linda is a bank teller. That's the most probable answer. And it also explained why, because of the conjunction fallacy experiment that came up, right? It also explained. In my second case, what I said is, I just tweaked this question a little bit. I said, I met a girl. So I'll just give you a gist of this prompt. I just spoke to my TTS, and there might be some changes how TTS picked up my words. But essentially, what I said, that I met a girl, and she was around 18 years old, very outspoken. She's actually been talking in multiple forums about ethics and security, about people's choices, etc. Now her birthday is coming, and I want to gift her something that is very close to her profession, right? And nature. So based on all the information that I gave you, what do you think is the profession, or which of these two statements you think are right? Right? So, and then I asked it that, can she be a maths student, or can she be a maths student and activist who fights for people's rights? Right? It's the same conjunction fallacy asked in a different way, creating a different scenario. And if you look at the answer after thinking for 6 seconds, it says math student and activist who fights for people's rights, which is wrong because it's less probable, right? Then the fun began. What I said, what if she's 31 years old and her name is Linda, and she was deeply concerned with issues of discrimination, of social justice, and also participated in anti-nuclear demonstration? Then it says, yes, my answer should change. She is a math student only. And then it spoke about conjunction fallacy. The words 31 years old, the name Linda, the social justice has made it understand the pattern, right? Instead of reasoning. You remember the common sense of human and reasoning models that I was talking about? This is a perfect example of that, right? And now, towards the end, I'll give you one use case that I personally was involved in building that is currently working, is creation of a software engineer, right? Agentic software engineer. So if you look at the current flow of software engineers, and let's say we are talking about Jira. So when a software engineer looks at Jira, like, and then repeats these certain steps at a given point of time. So he or she tries to understand the issues raised in Jira, looks at the timestamp in logs in Jira. Then if there is a timestamp, the such shows that, okay, there are some timestamp is there, and if the Jira is properly explained, the developer tries to do an RCA, then checks out the repo from the GitHub, fixes the bug. Then it goes to the tester. The tester says that, okay, the bug is fixed or not fixed, give their feedback. Then the developer raises the PR and then changes the status in Jira saying that, okay, dev done or QA done. Someone has to review my code and merge it. So this entire process we have automated. How? With the introduction of something called Viva Software Agent while you were away, right? For the last 6 months, we have developers having something called Viva Agent. So after developers go back in the evening, the Viva Agent starts picking up Jira bugs that is assigned to that developer. And this Viva Agent has multiple agents at its disposal. The first agent tries to understand the issues raised in Jira, right? And then gives feedback to agent 2. The agent 2 looks at the timestamp in the Jira and tries to understand that, does it understand or does it have enough information to go ahead and start fixing this problem? If yes, then it starts. If not, then agent 3 creates an email to the stakeholders with RCA and further question that agent 2 needs to know. If all good, then agent 4 actually checks out the repository from the GitHub, fixes the bug, and then agent 5 tests the bug, and there is a to and fro that happens between agent 4 and agent 5. Then agent 6, or in right now even the developer agent itself, can actually raise a PR, right? And then the YY agent actually changes the status in the Jira. And then this process is repeated again where the agent picks up the next Jira that is assigned to the developer. Now the software engineer comes in the morning, looks at something called what we call YY dashboard, and looks at how many PRs were raised while he or she was away. And the developer's job is to basically go ahead and see whether the PR is right. Do the code review, if all right, and then go ahead and merge it with the main. Now, when you create this system, this is such a powerful system, but any agentic system will also need matrix to be basically keep in mind. So in this case, and this matrix basically depends on what use cases that you are working on. So in this specific case, what we actually capture is how many of these PRs that are there in the dashboard can directly be merged without developer adding any more codes or any feedback. The next set of the next matrix is how many of these is where developer has to actually to and fro have to talk to the agent to fix something more, right? Before it actually goes ahead and merges to the main branch. And the third is where the agent has absolutely failed and it could not do it. So as of today, we have around 20 to 25% where the developers are just merging it. Around 60 to 65% where the developers is actually talking to the YY agent and getting things fixed. And then around 15 to 10%, 10 to 15% cases, AI is not able to do that. And when we track this month-wise or sometimes bi-weekly wise, the idea is that the top part where 10 to 15% should first come to the second middle part from 60 to 65%, and then 60 to 65% should start moving towards AI only, where the developers is not at all involved. The reason for telling you this is that the matrix is as important even for agentic use cases. This is needed for all use cases, but even for agentic use cases, so that you can iteratively improve this type of agents. Now, when it comes to autonomous quality engineering, there are a lot of things happening through agents as well, right? So there is automated testing, and then there is autonomous testing, right? So we started with automated testing where we have something like Selenium, something like Playwright, etc., where we write our UI test and basically try to replicate user behavior and see whether it is working fine or not. Now, in autonomous testing, Agentic employs search-based software engineering, right, to dynamically explore application without fixed scripts. Now, how does it make a difference? So in a button, if the button ID gets changed, your automated test would have failed. In autonomous testing, the agent is not only figuring out that the button ID is changed, but it is trying to figure out how to click that button. I can see the button. It can see the button here, right? It doesn't need to know the ID or XPath behind the scene to basically click that button, right? And there are a lot of tools available in the market today where autonomous testing is actually happening. If you want to quickly try it out, Perplexity has a browser called Comet. You can install it, it's free of cost, and try to ask it a question that, hey, I want to see this movie in my nearest theater and I'm sitting here. Can you go ahead and select the best possible seat? And you'll see the magic happening. It will go ahead and open Book My Show or something like that and try to basically add a seat that is best in the available seats that is there, right? So there is one more, there's Meta has a Sapiens agent that Meta has created, and it uses something like an evolutionary algorithm to generate sequence of user interactions, clicks, swipes, inputs without human guidance. So this one is specifically for mobile applications as of now, right? And it runs kind of 24 hours doing two key metrics that it tries to cover. One is code coverage, like touching every part of the code base, and then crash discovery, identifying edge cases to break the app. So it continuously tries to break the app. You can imagine that this is equivalent to something like we used to call exploratory testing, right? So when you do the exploratory testing, you give the application to a bunch of users in multiple devices and ask them to basically go ahead and test it without any context of the application and see if they can break the application. So impact at a scale, when Sapiens is concerned, we have it is in writing daily test cases close to 10,000 plus, right? Continuous operation is 24/7 up, and false positive has reduced significantly when because of its testing and the edge cases that it has found out. So the point is that even in this industry, we have figured out that there are a lot of things happening. Agents are actually helping the QAs to basically go ahead and perform their task a lot faster and more productive way. So that's it. I hope it gives you a understanding of agents, a basic understanding of how agents work and what are the things that you have to keep in mind. Some of the basic concepts of reasoning versus thinking. Is it really thinking? There is a paper called Illusion of Thinking, published by Apple. You should get the PDF and read about it. It's fascinating. If you have time, this can be your, if weekend is coming, then this can be your weekend read as well. This is amazing. It's available over the internet. But I'll end this video here without going deeper into it. Maybe we'll create focus videos around agents and how to create agents with agentic frameworks that are available like Crew AI, AutoGen, etc. But in this video, the idea was to give you the foundational understanding of what agents and how should you choose the agentic use cases in your organizations. Thank you so much for your time, and I'll see you in the next video.